Good day to all. Today the topic is linear regression model. Myself Dr. B. Suresh Kumar, Department of Mechanical Engineering. Nowadays the engineers they may be a science person or needs a mathematical model for making a decision with their objective function. For that, how can we make the mathematical model? Generally, the mathematical model developed based on experimental setup means these models are known as empirical models. The mechanistic models are also utilized for making a decision, but nowadays different manufacturers are produce the different machines so that every machine required their own mathematical model for making a decision. For the reason this presentation deals about how do we make the mathematical model with regression analysis. The engineering and the science problems need the mathematical relationship based on experimental approach called empirical models. For these kind of problems, statistical techniques playing important role. In sense, how nowadays regression analysis is utilized. So, what is meant by regression analysis? Regression analysis is used to make a relationship between two or more variables. The simple linear regression. Regression has its own types, which is simple linear regression and multiple linear regression. This class deals with the simple linear regression. Next video I will tell about multiple regression models. This video will be presented about simple linear regression. So here the mathematical equation is available. The term y is equal to beta naught plus beta 1 into x plus eta. Likewise equation available. Here I framed the equation with the aid of y and x variables with the coefficient of beta naught and beta 1. So the equation contains one variable means these are all comes under simple linear regression. So that in our engineering experiment or science experiment, the simple linear regression models also needed for making a decision. So eta, in that equation the term eta is also available, which means which means the error available with our experiment, because our equipment also develops the error and the measuring instrument also develops error, so that we can aware about the data variation between the n number of experiments, which is known as epsilon function. Here why it is called as simple linear regression? Because it has single independent variable which is x, so that this is known as simple linear regression model. In above equation there is only one regressor or predictor called x and the response variable which is known as dependent variable, which means y. Okay, these two variables only available. One is regressor, another one is response. Okay, and then for understanding we may utilize example problem from Montgomery book. Okay, the applied statistics and the probability for engineers and scientists. From this I can pick a problem for understanding purpose. The problem, the observation number 20 observations available for purifying the oxygen in our experiment. So they vary the hydrocarbon level. Here the hydrocarbon level is the independent variable and the response is purity. So they are conducted 20 experiments. In that n is equal to total population size, which is 10 observation available with this experiment, so that n is equal to 20. Then xi is to be identified. The sum of our values with respect to x tabular column. With this experiment hydrocarbon level is known as x, so that summation of I is equal to 1 to 20, because 20 observation available with our experiment, and also xi is equal to 23.92, so that summation of x column is equal to 23.92. Similarly, we conduct the summation with another access purity value, which is yi. Here also 20 observation available. I is equal to 1 to 20. Yi is equal to 1843.21. Here I is equal to 1 to 20, and then I making a squared of x column and y column. Here sum of I is equal to 1 to 20, xi square is equal to 29.2892. Similarly, yi square is equal to 1,70,044.53. Likewise, I got, after that, summation of I is equal to 1 to 20 xi y, the product of xi and yi, I can get 2,214.6566, and then I may identify the summation value and also average value, so that x bar is equal to 1.1960. So sum of x column value divided by 20, I can get 1.1960. Similarly, I have to find y bar value from the purity column. Y bar is equal to 92.1605%. Then the finding of coefficient value is the next step, beta naught and beta 1 from experimental value. For the reason, I identify these things, sum of as xi, summation of yi, likewise x bar, y bar I got from calculations. Okay, here I go to finding out the coefficient of this simple linear equation, which means b0 and b1. For identifying b0 and b1, I utilizing the sxx and syy formula. Here beta 1 utilizing formulas like sxx divided by syy, so that we should identify sxx through the formula of summation of I is equal to 1 to 20 xi square. Now you may aware why I find the xi square and yi square values with this available tabular column, observed tabular column from experimental setup, so that I utilize the value I is equal to 1 to 20 with xi square minus sum of I is equal to 20 xi the whole square divided by 20 is equal to, I substitute the respective value on that xxx equation. Likewise, I utilize syy equation for developing the value for xyy with the summation of I is equal to 1 to 20 xi, I is equal to 1 to 20 yi divided by 20 with the xi square. So that now you are aware about why we identify summation value, why we square the summation value in previous slide, so that we find the value of sxx and syy for identifying the coefficient values, which is b0 and beta 1. Okay, here how for identifying the beta naught, I should get the value of beta 1. So that first preliminary I find out the beta 1 value is equal to, there is formula available, which is xxx by syy. Already I found the value as for xxx and syy. From that I substitute the values with that beta 1 bar equation. From that I can get 14.94748 value. Similarly, for identifying the beta naught, I utilize y bar minus beta 1 x bar, so that I can substitute the value what I got from y bar value in the experimental tabular column and what I got from the experimental tabular column for x bar. So I substitute the value on y bar, x bar, and also I identify the beta 1 bar value from this equation. So I substitute all the values with the respective equation. I may got beta naught value, which is 74.28331. Likewise I got, and then final linear regression model, I substitute all the values associated with the experimental data collected from experimental setup. I substitute the values with the simple linear regression model beta naught, beta 1. Okay, from this substitution I may get the equation like y bar is equal to 74.283 plus 14.987 into x. So here I substitute the identified values for beta naught and the beta 1 in the simple linear regression model equation. Okay, and then the third value is available, third term is available, which is epsilon eta. Okay, for identifying the epsilon value, I utilizing the formula EI is equal to yi minus yi bar. Here EI is the residual or error in the fit of the model, so that we should identify EI value also. So how do I identify EI value? With this tabular column, I substitute all the hydrocarbon level in the equation of y bar is equal to 74.283 plus 14.987. For the value of x, I substitute the value what I got from my experiment, x value 0.99, I substitute in that preliminary equation which I got from my experiment. Okay, so I may get the 90.01. I substitute 1.02, I may get 89.52 and 91.43. Likewise, I got 20 predicted value from 20 observations. Now I subtract the values, available value 89.07 with the experimental value, I may got 0.94. Likewise, I may got the difference from standard equation, which is known as the deviation between the experimental and the predicted value is the residual obtained from my equation and the predicted value and the experimental value. Here, coefficient of determination. Every empirical model contains R squared value, which means curve fitting value. How do I identify this curve fit value? Curve fitting value means R squared is equal to SSR by SST. For the reason, I may go for identify the SSR value. For identifying SSR, we may utilize beta 1 into SXY. Already we know about beta 1 value from our previous calculation, so that I substitute here, and the SXY also know. I substitute the values, I got 152.13, and SST I utilize the summation of I is equal to 1 to n. Here the 20 observation available, so that y20 square minus n means population 20, y bar square. I substitute the respective value on this equation, I may got 173.38 as the SST value. Finally, I substitute the values on SSR and the SST, I may get the coefficient of determination value, which defines the efficiency of my predicted developed mathematical model, 0.877. Lot of journals suggested that the predicted value is more than 0.8, means we can accept the model for further investigation. From this experimental setup also, I can get 0.87 value, so that I can utilize this model for further prediction of the hydrocarbon level with this model. So now you are aware about how do we develop the mathematical models with the aid of experimental data collected from experimental setup, which is known as initial regression model, which is simple linear regression model. We can develop the n number of mathematical model from our laboratory experiment also. Thank you.